library. So to go ahead, let's understand what is the Numpy library. We are taking this reference from Python Data Analytics with Pandas, Numpy and Matplotlib, second edition, wherein we are referring to chapter number 3, the Numpy library. So the Numpy library is actually created by Fabio Nelli, and he's the copyrighted owner of the Numpy library, wherein he has actually referred to Numpy library in this Python Data Analytics document, which can be accessed at doi.org. Now to give you a quick brief of what Numpy is. So Numpy is a library which is actually used for scientific computing with Python. When you use Python, there are a lot of times that you need to use scientific or mathematical equations, and you need to use n-dimensional data structures. To support both of these issues, like scientific equations, mathematical equations, and data structures, Numpy is one of the best package available. Now this package, hence due to both of these features, it is used for data analysis in all major issues wherever data analysis has to be done. So this library is the basis of large amount of mathematical and scientific Python packages which are included in this. So we are going to use this library, and it is very easy to use this library. So let us just quickly open Google Collaboratory and let's get started with a new project. So here we are going to have a discussion on Numpy library. The first thing is how to use Numpy in Python. That's the first question. So we can import Numpy library using this import sequence by calling import keyword and specifying the library Numpy. And you can create an object of Numpy library using as keyword, and then you have to give the name of the object of Numpy library. So NP becomes an object. Now if I explain you here, import is a keyword in Python using which you can import a package. Then you have to provide the package name. The package which we want to access is the Numpy package, which gives us access to scientific and mathematical equations along with array structures and various other n-dimensional data structures. And then you are going to create an object using as keyword, and name of the object will be NP. Okay. So once you're done with that, we are going to quickly test this. So before that, let us quickly connect to the Python instance so that our script gets parsed and we are going to get the output. So once we executed NP and we run this cell, now from the next cell onwards or from the current next statement onwards, you will be able to access all the functions available within Numpy. So you can see there is a dot here. This dot is scope resolution operator. We call it as scope resolution operator. And then there are various methods available within Numpy. These methods are ABS, absolute, absolute import, add, all, and there are so many. There are a lot of methods available in it. Okay. So we are going to understand all these methods in sequence following our documentation. So let us just quickly explore what all things we can do with Numpy library. So here with Numpy library, what next we can do? Numpy provides you built-in tools. Using this Python standard library, you can actually perform calculations in data analysis. This is one of the most important part. Having knowledge of Numpy library is important. You will be able to use all the scientific Python packages, and you will be able to perform these computations easily. So this is a quick overview of Python Numpy library. And let us just quickly understand a little history of Numpy, how it all started. So there was a time the developers needed to perform numerical calculations. Okay, So the first attempt was numeric, developed by Jim in 1995, which was followed by an alternative package called NumArray. Okay. So in 1995, there was a package known as NumArray, which was used in Python to create arrays in Python. Array is by default unavailable in Python programming language. The basic data structures of Python do not offer us to create an array. Hence, in 1995, there was the first library known as numeric, and second library was NumArray, which was available. Both these packages were specialized to calculate the calculations on arrays. Okay, and they were differently used for different circumstances. But there was a problem. There was an ambiguity due to these packages. The idea of unifying the two packages by Travis Oliphant started to develop the NumPy library for this purpose. So what exactly they did, they combined numeric and NumArray. Numeric and NumArray has been combined into one library, and the name of the library is NumPy library. So NumPy library was first released in 2006 when its first version, which is version 1.0, was released. From that moment, NumPy proved to be the extension library of Python for scientific computing. So whenever you need to perform any scientific calculation or a mathematical equation, the first library which anybody will seek is NumPy library. Okay. NumPy is most widely used package for calculation on multi-dimensional arrays and large arrays also. So whenever you have an n-dimensional array or whenever you have a large array, then we perform calculations using NumPy. So these are certain things which we use NumPy library. In addition, the package comes with a range of functions that allow you to perform operations on arrays in a highly efficient way and perform high-level mathematical calculations. So just to bring the whole idea quick, NumPy is a combination of numeric and NumArray, and it helps you calculate mathematical calculations and scientific calculations easily in Python. And importing this package is very easy. Okay. So now let us just quickly go to the next slide. How can you install NumPy? By default, NumPy is already installed in the Linux machine when you install Anaconda Navigator. But let's say somehow if you don't have NumPy available, then you can use this command sudo apt-get install python numpy to install that on a Linux-based machine. Okay. If you want to quickly test that here, I would like to quickly add up a cell, and let's put the cell here. So let's see how to install NumPy library. So to install NumPy library, you have to execute a Linux command. And on Google Collaboratory, we can execute Linux commands using exclamation operator. And you can actually define sudo apt-get install. We cannot do sudo as we are running over the internet. So we'll quickly define apt-get install NumPy Python. Okay. So you can quickly install Python NumPy. And when you run this cell, you can see that there will be a certain process which will start, and you can see that Python NumPy is already the newest version, and we do have the available dependencies available also. So in case if you don't have NumPy available by default, you can install it using apt-get install Python NumPy. Is this process clear? Great. Now, so what next we have? So you know how to install the NumPy library, how to import the NumPy library. Now let's proceed next. So once this has been imported, then you can use or import NumPy using import NumPy as NP. You can always change the name of this object. Okay, it is actually used by user. NP is very relevant to NumPy, hence mostly you will see in the codes that people use NP as the object, but you can use any possible name, whatever you like. Okay. Now let's go for the next step. So one of the most important part of NumPy is its n-dimensional array, because it integrated the features of NumArray. So we want to understand how we can create arrays using NumPy. Okay. Now, the NumPy library is based on one main object, and that is known as n-dimensional array. This object is a multi-dimensional homogeneous array. So multi-dimensional as in you will be having multiple columns within the array, and it is a homogeneous array, which means the data type of the array will be same. So if you have the integer array created, then all the elements within that array is going to be integer. If you have created a string array, then all the elements within the array is going to be string. Now, with a predetermined number of items. So you have to actually allocate the memory when you create the array. So you have to define the number of items which you want to hold into an array. Okay. So this is one important thing, n-dimensional array, which you will be learning. Now you can see that the data type is specified by another NumPy object called dtype. So you can actually check the data type of NumPy using dtype object. Each n-dimensional array is associated with only one dtype, okay, which means only one data type, one kind of data can be stored into an array. If it is numbers, then only numbers can be stored. If it is a string, then only strings can be stored. Okay. Now, the number of the dimensions and items in an array is defined by its shape. So shape actually defines number of rows and number of columns. So shape actually tells you, let's say if we have a table and table has 5 columns and 10 rows. So the shape will be 10, 5, wherein the first value represents number of rows and second value will represent number of columns. So you can get actually the shape somewhat like this. Let's say shape of an array could be something like this, 5, 10. So this actually means 5 rows cross 10 columns. Okay. So this actually is the shape of any of the array. And the values will change depending on our requirement and our creation. So you're going to get a tuple of n positive integers that specifies the size for each dimension. So the first dimension is row, second dimension is column, and the size of first dimension is 5 and second dimension is 10. The dimensions are defined as axis and the number of axes as rank. So since we have 2 axes here, one is x-axis, second one is y-axis, hence the rank of this array is going to be 2. So depending on the number of axes or the number of dimensions you have in an array, that becomes the rank of your array. Okay. Now, NumPy arrays has a fixed size. Once you have defined the size, then at the time of creation, then it will remain unchanged. You cannot change the size of the array once it is created. Okay. Hence, the behavior of NumPy arrays is different than Python list, where Python list is scalable, wherein it can grow and shrink in size depending on number of insertion of the data in list and number of deletions out of the list. Okay. Is this clear? Are you able to understand? Okay, great. Now, the easiest way to define a new n-dimensional array is to use this function array. So how can you define an array? Just you need to type array function within your Python code and automatically an array will be created. Now when you create an array, you can pass a Python list containing the elements to be included in it as an argument. So you can define the array function, and within an array function you can define a list of items which you want to be added onto that array. Okay, and when you check, you're going to get an array type in return. So let us just quickly draw that. We are going to draw this step, and then we are going to check the type of the array, what type of array is created. So you can easily check that newly created object is an n-dimensional array by passing the new variable to the type function. So type is going to display you the type of the array, the type of the object. And when you have to check the individual value which can be associated to this, then you can check that using D type. Okay, D type is going to tell you what type of array it is. Is it an integer array? Is it a string array? Or is it a any other data type based array? So let us just quickly check back. So what we are going to do, we are going to create an array of numbers. Let's say we are going to create a simple array of numbers. So what we can do, you can use NP, you can call the array function array. This is the function array, and there are other options as well. Array to string, array equal, array equivalent, array split, array string. There are various options available. So I actually defined array, and let us just quickly take the quick help on array. So if you want to take quick help on array, you can actually define a question mark before you call the function. Okay. So what this function will do, this function array will actually help you create an object, create an array. Okay. Now when you are able to create an array, what all parameters can be given? So you can give an object. This object should be an array-like object. Any object exposing the array interface, so that can be given. Then you have the D type, you have the copy, you have order, and there are so many things available when it comes to n-dimensional array. And the final output is an n-dimensional array will be returned back to you when you create that. Okay. Now, so there are various arrays. You can create an empty, one like, zero like, full like, and there are various types of arrays possible. Okay. Now, so let us just quickly create an array. Let's check the type and the D type. To create an array, we called np.array. Then we passed in a list of, let's say, 10, 20, and 30. We passed in 3 values, and I call it as my array. Okay. Now, I would like to check the type of my array. So you can quickly check with the type function that it is an n-dimensional array. So Numpy is giving you this object, n-dimensional array. I hope this is clear to you. So we can create an n-dimensional array by simply calling a function and passing a list of numbers. Now we need to check whether the type of array is integer or string. Okay. So for that, what you can do is you can quickly call my array, and you can quickly check the property D type. If you want to get a quick help on D type, you can quickly check back here. So D type is going to give you the type of the variable, and I'm going to test that here now. So when I run this D type, you can say, we need to remove this question mark, we need to run it again, and you can see the data type for this is integer 64, which means at each place in the multi-dimensional array, a 64-bit integer value is stored. Is this clear till now here? I'm also sharing this link with you. Okay. So I've copied this link and I'm sharing the link with you. So the link has been sent. You can open that and you can see that you are on the same code. Now, so now we got to know we can actually create an array. We can check the number of dimensions, and we can actually check the type of the variable or data stored within the array. Now, what next you're going to do? In order to know the associated data type, you have already checked that with D type. Now I need to show you the shape. Okay. So you can see that the current array which we have created is only one axis because it only has one column. Hence it rank 1. The rank of this array is 1. While its shape should be 3, 1. To obtain these values from the corresponding array, it is sufficient to use the end-time attribute to get the number of axes or the dimensions of the array. Okay. So now what we are going to do, we are going to check the number of dimensions of the array. So you can define my array and you can use this property enddim. Okay. So we can quickly define a print statement and you can quickly print the number of dimensions of your array. So it is a one-dimensional array which you can actually check using enddim. Is it clear? Great. So now you already know how to check the number of dimensions of the array. If any array is given, you can actually check the number of dimensions of the array. Now post that to obtain these values from corresponding array, it is sufficient to use enddim attribute for getting the axis, the size attribute to know the array length, and the shape attribute to get its shape. Okay. Now we would like to get to know the array length. So since we have 3 items, we are going to check the length of the array. Check the length of array. So to check the length of the array, you need to check back with the size. We're going to define my array dot size. And you can see that the length of the array is 3. Because I have added only 3 entities into it. Okay. Great. So Punima, you are doing along with me? Okay, great. Now, so let's proceed to the next step. So the next step is you have got the dimensions, you have got the size attribute to know the length of the array, and you have to get the shape of the array. Okay. So we got the length. Now we have to check the shape of the array. So shape of the array will be done using myArray.shape. So when you run this, you're going to get a set, and this set is going to tell you the number of rows and the number of columns. So the number of rows is 3 and number of columns are 1. Now you can see that you have seen a simple case of one-dimensional array. Okay. Now what we are going to do, we are going to create a multi-dimensional array. So we are going to define a 2-dimensional array with 2 cross 2 matrix. Okay. 2 cross 2 means we are going to have 2 rows and 2 columns. So this is going to be your first row and second row. This is going to be first row, first column. This is going to be second row, first column. This is going to be second row, first column, and second row, second column. Then we are going to check the data type. We are going to check the size. We are going to check the shape. And the array has rank 2 since it has 2 axes, each of length 2. Okay. So let us just quickly test back, and we're going to create a multi-dimensional array. So this time we are going to create a multi-dimensional array. To create a multi-dimensional array, you can directly call np.array. Okay. Within np.array, you can actually define the list. So this is going to be the first dimension. This is going to be the second dimension. First dimension is going to be, let's say, 1.3, 1.4, and second will be 1.1.3, 2.4. This is going to be 2.4 actually. Okay. Then you have 0.3 and 4.1. Okay. So we got this multi-dimensional array. Now for multi-dimensions, you have to use one more curly braces here, so as to display it multi-dimensional. So the square brackets you are using here actually represent the dimensions. So if you are using a double square bracket, then this means you have got a multiple dimensional array. Now, once you have got the multiple dimensional array, let us just check the data type of the array. Okay. Check the data type of the array. Okay. So what we can do, we can type in my array dot d type. Okay. So we are going to check the data type of the array, and this is going to be integer 64-bit. So all the numbers which we have created here are integer 64-bit numbers. Okay. And this is actually for the previous one, the my array which we created earlier. This is going to be the new array. So I will call it as 2D array. 2D array. Okay. And now let's see, I'm going to change it from my array to 2D array. And now I'm going to run. So now when I run, you can see that we get that the D type of that is got a two-dimensional array with okay, I have written it mistakenly. We have 0.3, 1.3, then we have 0. Sorry, how come it missed actually? 1.3, 2.4, 0.3, 2.4. Let's say these are the values, and the second value is 0.3 and comma 4.1. Now it becomes the one-dimensional array. Let's run it. So here now you can check you have got the float type array stored within inside 2D array. Is this clear? If you have any question, okay. Now, what next we have is, now you can check the dimension, size, and the shape. So just go for it. You need to print the dimensions, size, and shape of the two-dimension array. Okay, guys. So let's just check back. We are going to define two-dimensional array dot n dimensions. This is the number of dimensions. Number of dimensions are 2. Then we have the size, wherein we have two dimension array dot size of the array is 4, and then we have to check the shape. So two dimension array dot shape is equal to 2. Okay, so you can define the shape, and we can actually directly print the shape just to check back what is the correct shape. So this is two dimensional t small. So it is 2 cross 2, which means 2 rows and 2 columns. Okay. Great. Now there are other parameters like item size, which can be used with n-dimensional array objects. It defines the size in bytes of each item in the array. Okay. So let's say if you have 10 items. Now when you run item size, then each item will be replicated and all the size of every item will be displayed back to you. Okay. Now to do that, how we do? We are going to check the item size of the data. Okay. So let's say I have my array or two-dimensional array, and I need to check the item size of the array. Okay. Let's give it 2D array, two-dimension array dot item size. So when we run this, you can see that we have got 8 items into the data set. Okay. So it's 8 bytes. Every item is of 8 byte. Okay. So now this is clear. Every item is 8 byte. Now we need to create an array. To create a new array, you can follow different path. The most common path is the one you saw in the previous section through a list or sequence of lists as arguments to be an array function. So we are going to see how we can quickly create new arrays. Okay. Now there are certain mathematical operations which will start from here. So first, let's read about the basic operations. As you can see, Numpy array and how many items can be defined, that has to be checked. Now it is the time to see how to apply various operations to them. After basic operations, we have to explore the arithmetic operations, which includes functions like arrange, list comprehensions, repeating the numbers, and so on and so forth. Okay. So let us just understand the first operations that you will perform on arrays as the arithmetic expressions. The most obvious are adding and multiplying an array by a scalar. So now what we want to do, we want to take up a range for up till 4th value, and we are going to add this 4 into our array. Okay. Now, so let's say, so we are going to use a range. Using a range to create a list. So we created that using a range 10 to 15. Okay. So you have to print in a range value. So a range is also available in Numpy. So what we are going to do, you can use np.arange, and let us just quickly have the documentation so that you will get that clarity. So a range, whenever we define, we have to specify three parameters. The first parameter is the start symbol from where I want to start printing. Second is the last item which I have to ignore. So let us say the stop item is J. So we actually have to print the values up to J minus 1. Okay, which is one step before the jth position. And the third is the step counter. Step counter is something like to provide a condition that if the condition matches, then what should be the incrementation, whether it should increase by 5 times or 10 times or 2 times, whatever it is. Okay. So we are going to define a range, and we are going to define start, stop, and step. So what I just want to do is, I want to create a for loop which is going to print a value from 1 to 10, and it is going to skip all the second values like prime numbers. It is going to be a list of let's say odd numbers or something like that with one incrementation, something like that we're going to do. Okay. So let's say we are at a range wherein we have to define the start operation. So I say start from first, and since I want to print 10, so 10 is the last element, so I want to put it like 11. So stop should be 1 minus the stop word, whatever stop word is given. Okay. Now what should be the step? So let me just show you. If you run this np.arange, you are going to get an object from the value 1 to 11. Okay. When you run np.arange, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get a one-dimensional array. Let us just quickly save it into numbers, or let's say I'm going to say odds. Okay. So for odds, I'm going to increment by 2. Okay. So when I increment by 2, you can see that we get to have, you're going to print in from 1 to 11, and you're going to store that onto odds. And if you print odds this time, now you can quickly check you have got 1, 3, 5, 7, 9, which are the odd numbers. Okay. Now, if you want to check the dimension, size, and shape of odds. So it is going to be odds.mydim, ndim, that is n dimension. So it is a one-dimensional element. Then the size odds.size. Let's run this. So the size of the element is 5, and as you have already seen when I printed odds, if you want me to do that, I will print that again. So when we print odds, we only get the 5 values, which is 1, 3, 5, 7, 9. Okay. Now we need to check the shape of the odds. Odds.shape. Okay. Now when we run the shape, it gives us the overall structure of our array. So it says it has 5 rows and 1 column. Hence, the shape has been identified using Numpy library as well. I hope this is clear to you. Please confirm. Okay, guys. Now what you can do is, over this A range, you can perform arithmetic operators also. Okay. There is one more thing which you would be glad to see. Implementation of regular loops. Implementation of for loop in Python. Okay. So I'll give you an example. Earlier in C++, what we used to do, we used to define it something like this. Integer I is equal to 0, I is smaller equal to, let's say, 10, and I plus plus. Let's say this is one for loop which we have to implement. Then again, there will be another for loop. Let's say J is equal to 10. I is greater equal to 1, जब तक एक नहीं हो जाता, we have to implement I minus minus. Okay, we have to go in the reverse decrement order as well. So how can we set up both of these for loops in Python using a range? So now that's what we are going to define. So we are going to use np.arange. So we are going to start the number from 0. This is the start position. It will go up till 10th position, but since here equal to 10 is registered, so we are going to define 11 because we are good. To print until j minus 1, that is 11 minus 1, which is equal to 10. And what should be the step counter? So step counter is 1. So we can ignore it, we can print it. Okay. So when we print, you can see that you get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which is exactly which can be printed when you call this for loop. But what if you have to negate it? What if you have to display a negative loop? So to display negative loop, what exactly we are going to do? We are going to use np.arange. We are going to define, and I want the value 10 to be printed. Okay, and I would like to go to the minimum value of -1. Okay, or let's say 0. I will go towards till 0. And the third value will be -1. So we are going to decrement it by -1. So when I run this, so this time I get the output 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So this is how you can implement loops in Python. Clear? Great. So we got the for loops implemented, followed by, so you can see that there are a lot of functions like element by sign, square root, addition, subtraction, multiplication, matrix. A lot of mathematical operations are available. Okay. But since Numpy is a very important library and we only have one participant today, so what I would like to do is I would like to stop our today's session here so that we should not run faster because there will be other participants who will be joining us the next weekend. So we will complete our session today till here only, and just you need to put in the record on the on your Trello card or else anywhere on server, and just give us the link so that we can give it to the people. So that will be helpful, and in the next session we will be continue the sequence from here. So you have actually done till arithmetic operations wherein we implemented np.arange, and we will continue from here from the arithmetic operations. Okay. So we will continue from here so that people will get to know how we define multiple operations, how we use NumPy array with basic different operations, and then we will continue. Okay. So thank you so much for being available, Purnima, and kindly upload the video session post once it is ready for distribution. Just upload it on Trello card or upload it on a server and give us a link.